So let's say we have one circle. If I have one circle, what is the area of that one circle? Pi r squared. Now at some point we are going to integrate. Just keep in mind that pi is going to be kicked outside of the integral. That is our constant. Looks like my pen is missing. Let me go get it. Uh-oh. Okay, how many circles do I have for part B? How many? Two. Now, if you remember back in geometry, and the question stated, what is the area of the shaded region? Then y'all do big minus a small, okay? So let's say we're doing big minus small. And I want to look at the radius of the smaller one, and let's denote that with little r. The radius of the bigger one, let's denote that one with capital R. And they are two different lengths, so it's not the same r. So let's say we have big minus small, which is pi r squared with a big R, minus pi little r squared. What constant is common between these two that I could factor out? Pi can be factored out very well. So we have r squared minus little r squared. And again, when we do the integral, the pi is going to be kicked outside of the integral. So Milo, let's read the two ifs right here.
Okay, if rotated around the x-axis or any horizontal line, it's respect to x, and if it's rotated around the y-axis or any vertical line, it is with respect to y.
So rotate around the x-axis. So here's my x-axis. And let's say I'm spinning that around. That is going to be with respect to x. And when we have rotate around the y, here's my vertical line. And we're rotating around the y. All right, x on this one, y on this one. That's going to be with respect to y. Let's do a review on what we went over on 7.2 A and B, just as a refresher, okay? Because it's been a while. So on number one, Xavier, read number one.
Sketch the region bounded by the graph of y equals square root of x, y equals 0, and x equals 4. Find the area using the learning strategies with respect to x and y.
Okay, we're doing respect to x and y, so give me a little dividing line. On the left, let's do with respect to x, and on the right, let's do with respect to y. So with respect to x, this is simply review. So if I were to graph square root of x, it looks like this. And x equals 4 is going to be a vertical line at x equals 4 right here. And y equals 0 is the x-axis. And let's go ahead and shade in the piece that we are going to find the area for. And because this one is with respect to x, I want to go ahead and highlight blue on top, pink on the bottom. And let's pick a point on the top anywhere and point on the bottom. And that's going to make a vertical line, which is going to scan left to right. That's why it is with respect to the x. Now we have an order pair specifically on this one. So if I have 4, what is square root of 4? 2. So we know this value right here is 2. So that is 4 comma 2. Everyone okay with how I got to 2? Plug it in. All right. So then when I asked you to find the area of this one, it was, we're scanning with respect to x. So what's my low number and high number? 0, 2, 4. Very good. And it's going to be top minus the bottom. Top is a square root. The bottom is 0. Now, do I really need a 0 on that one? Not really. Okay, let's type this in so we remember where the buttons are. And I'm going to ignore the 0 piece. So we have math 9 from 0 to 4 of the square root of x dx. And that's going to give us the area of the shaded region. 5.33? Yes. And let's go ahead and make that into 3 decimal places as our norm for the AP test. So again, when something is with respect to x, everything has to do with the x. 0 is the x, 4 is the x, and the equation is in terms of the x. Good with that? Okay, now let's do a review on with respect to y. And let's draw the same thing since my, the ruler I'm gonna make on this one is gonna be horizontal instead. So draw the same one. That one's at 4, that one's at 0, at 2. Shade in the region. And this time I'm gonna highlight the right and the left. And pick a point anywhere on the left and the right, and as long as you're touching the pink and the blue, you're good to go. So that ruler is scanning up and down, hence with respect to y. So for the area, what is my low number and high number on this one? 0 to where? To 2. And it's gonna be right minus the left. My right is 4. Minus my left is y squared. And in case you're like, where do we get the y squared? If I take this equation and solve for x, that gives me x equals y squared. Okay? And that's gonna be dy. Okay, when we're typing this in on the calculator, can you use a variable y if you want? Yeah, okay, but then x is easily accessible, so why even bother? So go ahead and type this one in. The area should be the same. Cody, how many? It should be the same. 5.333. Does it also give you a fractional value on there? Fraction is fine. Non-fraction is also okay. But if it did, it should give you 16/3. All right. So now let's do the new topic where we have the revolution round to create the volume. So for the next piece, Ali, let's read. Find.
Find the volume of the solid generated by revolving the region bounded by the graphs of the equations about the given line. Draw a new picture for each part.
All right. We are using the same equation. So here we go. And it says for part A, we are going to revolve around what axis? X-axis. So if I spin this around, it's going to mimic on the bottom. And it's going to rotate in a what shape? A circle. And that's going to go from 0 to 4. When we rotate. So then I'm going to exaggerate this circle alone. So I think I'm going to highlight this. This circle, let's draw it really big to the right of it. And I know it looks like an oval, just trying to keep the 3D effect. And the part I want to focus on is the radius. It's all about the radius. So on my radius, let's go ahead and write out something. Up here is also up here, correct? That up here is part of the y equals x, square root of x. So y equals square root of x. At the center, y is equal to what number at the center? 0. And because I have one circle, we're going to use pi r squared. And as long as we know what the radius is, it's going to be very simple for us to do. So for the radius, it's going to be that minus this. So in our case, it's going to be square root of x minus 0. Now, do I care about the 0? You can carry that along if you want to, but I'm not going to worry about it. So then, our volume is equal to, what is my constant that I'm going to kick out? The pi. So bring that out. And our integral. And for this one, because it's rotating about the x-axis, it is with respect to x as well. So what is my low x and high x? 0 to what? We're going all the way to what number on the x? To the 4. And it says r squared. That is our r. So square root of x, all squared dx. And that's it. And it's going to solve the volume of this rotated figure. So let's go ahead and type this in together. For those of you guys without a calculator, go grab one right now. It's sad that you have a tool, but you're refusing to use it. I don't know what else to say. All right, So we know we have the understood parentheses that's going to cover for us. So I'm going to ignore that part. We have the x. Oh, I need another parentheses, looks like. And then squared dx.
25.
25?
Point 13.
I got 3.
What if I wanted in terms of pi?
I got 8 too.
I got 8.
Yeah.
An 8 pi. If you want to multiply out the pi and give me the decimal, that's fine. Okay? But to me, this is more perfect.
Oh, why do you not put the
All right.
I just forgot the 5.
You can put the pi. That's fine.
And it was 25.
So if we did times pi, we'll get 25, correct. But give me 3 decimal places though, okay? Looks good. All right, let's go on to part C. We're gonna do B and D on a separate sheet of paper for me. Y'all can try to squeeze it in, but I can't. So for letter C, what are we rotating about? Ooh, bless you. Ooh, x equals 4. We're rotating along the x equals 4. So let's draw the same figure again. We have the same figure, and that is at 4, and that is at 0. So I'm now rotating about this line right here. So if I spin this one around, would you agree that's gonna map onto the right side? Like kind of like a dome right here? So we know just by looking at this, our radius is gonna be down here. I guess more of like a semi or hemisphere. So let's exaggerate this. Here I have my circle, and I have something on the left and something on the right. And I want to actually look at this figure with this radius to that radius. What is this respect to?
Why?
Good. With respect to y. So let's go ahead and write out some figure. You guys all ready? We know the center of rotation was at 4, correct? So I'm just going to write out x equals 4. On my left is this left right here, and that is part of our square root. And that actually is, because it's just with respect to the y, x equals y squared. Because when I saw 4x, we get y squared. I need it in terms of y, okay? So now let's write out. I see one circle, so pi r squared is what I need. And we know we are going to kick out the what? The pi. And because this is with respect to y, what was a high number up here? 2. So we're going to go from 0 to 2. And let's go ahead and write out what the r means. R is equal to. It's going to be the right minus the left. That doesn't change. Top minus the bottom, right minus the left. So would you guys agree that is my right side? And that is my left side? So we have 4 minus y squared. And I'm going to put all that and square it because it says so. So we have 4 minus y squared, all squared, dy. Okay, let's type that in. And let's keep it in terms of pi to make the answer more accurate. You don't have to, but I think it's a good option. So hopefully everybody is typing. And I'm going to keep it with the x squared, and look what I did. I didn't put the extra parentheses. Boop. Go back.
I forgot mine.
Yeah, just go to second insert, parentheses. It'll shift everything over. I thought that was on my calculator, but it's actually on the board. Interesting. All right, when I press enter, we get some decimal. I'm gonna see if that's gonna make it into a fraction. Ooh, I like fraction better. You guys okay if I write out the fraction? You're like, do whatever you want. Boom. And yes, multiply out the pi if you want. All right. So this is pretty much the same logic, right minus left, top minus bottom, yes? Okay, so now let's see what would happen if I have a concentric circle, meaning a circle within another circle. Let's do part B. Okay. When I go over B, you're gonna be like, what just happened? So just bear with me. What are we rotating it about on this one? Y equals 1. Okay, let's go ahead and draw this first. So when I draw this, we get something like this and something like this. We're drawing. Cody, you have a pencil, use it. And we're rotating around y equals -1. So y equals -1 is right here. So this is a line that we are going to rotate about. So y is equal to -1. And we're spinning around this right here. So when I spin it around y equals -1, would you agree there should be another gap on the bottom too? The amount of space between this one should also be equivalent to the space on the bottom. And that figure on the top is going to map onto directly below. Ooh. So imagine cutting at y equals -1. What I see on top of that should be right on the bottom. Do we all see that? Okay? So then that means if I make a circle right here, we have another circle in the inside. So let's exaggerate this figure. Here I have a big circle with an inner circle with something in the center. So here I go. On top. Top is y is equal to square root of x. Is that true? And by the way, this is with respect to x. And then let's go to the next piece. This dot right here. What is this y is equal to on this dot? Y equals 0. Very good. Okay, down here that we were spinning about, that was y equals how many? We were spinning about where? -1. So what I'm trying to find on this one is, what is the radius of the big one? And then what is the radius of the small one? And then we can find the volume using the revolution. So for this one, we need to write out pi times r squared minus little r squared. Milo, are you writing with me? So let's look at the big R. My big R is going to be top minus the bottom. My top is radical x. Minus, what's the bottom? Could I say +1 instead? Minus a negative? Now let's look at the little r. On my little r, my top is 0, minus a -1 is +1. Hence, just the 1. And finding these two are probably the hardest thing. And after that, it's just going to be integrating with the formula given. So our volume is equal to, let's kick out the pi, integral. It is with respect to x. So what's my low number to the high number? 0 to 4 still remains. And it is a big R squared. So my big R is square root of x plus 1 all squared. Minus a little r squared, which is 1 all squared, which in the end is still 1 dx. And of course our calculator is going to automatically populate the parentheses. Let's type that in. And I want it in terms of pi. So we have 0 to 4. And then extra parentheses. Oh no, look what I did. I stayed within. Just gonna write -1. I don't think we need an extra. And then dx. Forgot minus. Okay, when I press enter, what do you guys get? 18 point. Ooh. So I'm gonna go ahead and round that to the third decimal place. So 18.667 pi. What if you left it as 6 as your last number on the AP test? Is that okay?
No.
It is okay.
Oh.
What's up?
Why on the graph, like the y plane or whatever graph, why is 0 under the -1?
Because right here, this is the x-axis. At the x-axis, our equation is y equals 0. At the y-axis, it is x equals 0.
I thought it was a coordinate.
Good? All right. Now let's go on to D. Now D says to rotate about what axis on this one? Y-axis. So this is with respect to what? To the y. Okay, let's draw the original image again. So here I have my image. as 0 to 4. If I am rotating around the y, that image is going to go to the what side? To the left. So I'm going to go ahead and draw that image. And what was the one that I showed you on the screen a while ago? This made what? What cake? A bundt cake. So then we have to the 2. And for the bundt cake, if I were to kind of magically cross section right here, it's actually going to create a concentric circle again. And since my original equation is all on the right, I'm going to look at the right side. 2 is the highest number on the y. Okay, my center. What is the equation of this center right here? X equals what? X equals 0. That was right here. The next point, the second point that I have it dotted, isn't that part of the square root? Yes? But then it's in terms of y, so I need x equals y squared. Now let's put a dot at the far right. I should put it over here. That's like bad teaching. The far right, x equals what? X equals 4. So this one, since we have a concentric circle, we have pi times big R squared minus little r squared. And let's see what the big R is. And if I highlight, here's my big R. And then here's my little r. For the big R, it's going to be the right minus left. What's on the right and what's on the left? 4 minus how many? 0, which is basically 4 that I'm going to use. For the little r, who's my right minus left? Y squared minus 0. Do I need that 0? Probably not. Again, getting that is the hardest part. The rest, we just mimic this right here. So we have our volume is equal to pi. And this is with respect to y. So what's the highest y value we're going to go up to? 2. And then we have the big R, 4 squared, minus little r, y squared all squared, dy. And then we have that magical parentheses. Go ahead and type that in. In terms of pi, please. Bless you. Should be 20 something.
25.6.
Yep. And was that a clean number?
Yes, ma'am.
Perfect. Let's do one last one on the back page, and that's going to be part A. Okay, on the back. Just the part A. Okay, Cody, go ahead and read number 2, please.
Find the volume of the solid generated by revolving through the region bounded by the graphs of the equation about the given line. Draw a new picture for each part.
We read the equations too.
Y equals 2x squared, y equals 0, x equals 2.
Okay, so let's go ahead and start with the first one. The first one is what shape? 2x squared is a parabola, and it's going to go through the origin since it doesn't have a y-intercept. It should be more narrow, but I need to make it more exaggerated so y'all can see the area bounded by it. And then y equals 0 is already right here, and x equals 2 is right here. Let's shade in that region. And this one says around the x-axis. So if I go rotate around the x-axis, that's going to be with respect to the x. So if I spin that around, this shaded region is going to lie on the bottom as well, correct? So let's go ahead and make that. And when I do, it's going to rotate with the circle as our cross section. And let's exaggerate this. Is this one circle or multiple circles? Just one, which is good. So I'm looking at, there we go. This radius. So let's put a dot. Here's my top dot. That dot is part of the parabola. So let's write y is equal to 2x squared. The middle dot, what is that y equal to? 0, very good. And since we have just one circle, I need pi r squared. And the radius for this one is going to be top minus the bottom. Who's on the top? 2x squared. Who's on the bottom? 0 that I don't need. So we know the volume is equal to, we're mimicking this formula. Kick out the pi. Because it is with respect to the x, we're starting at 0 and scaling all the way to where? To 2. Then I have r squared, so I need to take all of the r and square it, dx. Let's type that one in terms of pi, of course. Is a number interesting?
$25.6.
Yeah, 25.6.